Thanks, Tom. That was great. We're a little bit low on time, so I'm not totally sure we're going to get to all of your questions, but still, if you have them, submit them, and we'll try and answer them right after we hear from Greece. So, Danos, whenever you're ready, we're ready to hear from you.
My name is Ellinogermaniki. I am a physics teacher at Ellinogermaniki Agogi school in Athens, and me and my students would like to welcome you to our contribution for the 100 Hours of Astronomy celebrations. Our aim is to use the Cosmos Project to present a way of teaching physics in a more interesting fashion than the traditional way, the chalk and board way. We will use astronomical data to present this educational scenario, which is called how long a day lasts on Jupiter. We have used telescopes and data sent from Galileo spacecraft and Voyager and all other sources to make this more interesting. As you can see, this is an animation, but this is actually what the Galileo spacecraft last videotaped before it fell down on Jupiter. Actually, Galileo spacecraft was orbiting the planet for about 8 years before it crashed down. The data collected some of those will be presented as follows. Can anyone spot something specific, something distinct on the planet's surface, so that we can manage to pick a spot and see how long it takes to rotate the whole circle? Dimitris?
There is a red spot on the left.
You mean this one, right here?
Yeah.
Right. This is actually observed for over 300 years. First observed by an astronomer called Cassini. And I would like you to try and think what this big red spot is. What could it be? Menos?
Maybe a crater.
A crater. That's a good point, but let's have a closer look. As you can see, this is no crater. It rotates by its own axis, and it appears to be, and as far as we know, is an air turbulence. It's like a hurricane. Not exactly as we know it on Earth, but in much greater strength and duration. Anyone providing ideas why it takes so long for this hurricane on the surface of Jupiter to rotate? It's more than 300 years old, and it will probably go on for a long time. Yorgos?
Maybe because of its size.
Its size? Yeah, that's something I would like to discuss with you. We'll see in a minute the size of Jupiter and the size of this big red spot, how big these two things are, and we'll compare them to Earth. But any other reasons? Its size is obviously one of the factors. Dimitris?
Maybe the heat of the planet.
No, it's temperature. I don't know if you know that, but Jupiter is a gas planet. There is no soil. You couldn't land on Jupiter. And if we compare this hurricane to a typical hurricane on Earth, then we could consider friction as to be one of the factors that doesn't exist so much underneath the surface of this red spot. Having not so much friction, this could go on for a great long time. Jupiter is the 5th planet orbiting the Sun. Earth is the 3rd in a row. I want you to take a good look at Earth's size and Jupiter's size and try and imagine how many times Earth could fit in Jupiter. Konstantina?
Maybe 500.
500 times. Anybody else? Magnus?
1,000?
Any better offers?
1,000?
More than 1,000. And if you were about to think of Earth compared to that red spot, Manos?
Maybe 2 times.
You think that Earth is bigger than the red spot twice, or the spot is bigger than Earth?
No, the spot is bigger than the Earth.
Let's see. Let's have a look.
The outer solar system, realm of the giant gas planets, is the true home of the superstorm. The planet Jupiter is so vast that more than 1,000 Earths could fit.
As you can hear, it's actually more than 1,000 times.
Planet that's all.
Earth can fit about 1,300 times
As long
in
ago
Jupiter.
as the 17th century, the astronomer Cassini saw a mysterious dark shape moving on Jupiter's surface. The Great Red Spot turned out to be a type of hurricane.
The Great Red Spot is so big that twice the size of Earth could fit in there.
Now, after more than 300 years, the Great Red Spot
This is an actual video taken from a spacecraft.